Now coming to the next topic, characteristics function. Now in this characteristics function, till now we have studied about moments. In the moments again we have studied in detail about with respect to the origin as well as with respect to the mean. Now over here characteristics function is basically used for finding the moment generating function wherein the function cannot converges. What do you mean by the thing cannot converges? We have seen that the moment value that we were getting is integration from minus infinity to plus infinity. The function, the moment generating function mx of t is equal to minus integration from minus infinity to plus infinity e of tx fx dx. Now when the function do not converges, that means after we solve and it comes to a zero value, then it says that it cannot converges. And also the series which cannot converge. When you say series that cannot converge means the moment generating function mx of t in terms of series is given as summation from I equal to 1 to n. Same thing into e power tx p of x. These two things in terms of integration as well as in terms of series, when they do not converge, then that happens for few distribution, not for all. When it happens, then we go for the characteristics function. Now the characteristics function is also defined for the case of random variable x. This random variable x is given as, with respect to the random variable x is given as the characteristics function phi x of omega is equal to expected value of e power j omega x. Okay, phi x omega is equal to e, this e means expected value e power j omega x. Now how we have seen for means as well as for moments, both the cases, that is continuous random variable and for the discrete, similar manner for the case of characteristics function also it has been classified in two categories. One is for the continuous random variable, another thing is for the discrete random variable. Now for the case of continuous random variable, the characteristics function is given as phi x of omega is equal to expected value of e power j omega x is equal to integration from minus infinity to plus infinity e power j omega x f x of x. This is what probability density function. This is the function with respect to the characteristic function. Okay. Now similarly for the case of discrete random variable, from continuous to discrete, the changes that takes place is over here we have integration, but over here we have summation. Here we have probability density function, over here we have probability distribution function. So for the discrete random variable, phi x of omega is equal to expected value of e power j omega x is equal to summation e power j omega x p of x. So this is the characteristics function for both continuous as well as discrete. Now how we have seen the properties, various properties for the mean moments, similar manner we have certain properties for the case of characteristics function. The first property says that the modulus value of phi x of omega is always less than or equal to 1. That means it should not exceed any value greater than 1. Second says that the value of phi x of 0 is equal to 1. Whenever the value of omega is 0, the characteristics function will take the value as unity. Third one is each of the functions are conjugate of one another. Phi x of minus omega is nothing but, or is equal to phi x of omega bar. They are conjugate function. Next property says that phi x of omega is a continuous function. Now this it is continuous over what period? It is defined for minus infinity to plus infinity for all the values, real values of omega. Next property says that it is an even function. What does this mean? The phi x of omega is equal to phi x of minus omega. Even though when we have the value of omega as negative, it will fetch us as the even function. Using the different constants, also we have one of the properties that says phi of ax plus b omega. Now over here the value of b is constant, okay, whereas a is also constant, but my a is attached with that of x. What is x? Random variable. So I'm just taking out the total constant values outside, so I can rewrite this as e power j b omega into phi x a omega, where a and b are constant. Next it says about how those two variables can be independent. If we consider x and y are two independent random variable, then phi x plus y omega is nothing but phi x of omega into phi y of omega. The sum will give us, can be written in terms of the product form for the case of characteristics functions also. Now the last property says that if x is a random variable with a characteristics function phi x of omega and the rth moment exists, it can be determined as m of r is equal to minus j power r dou r of phi x of omega by dou omega of r. These are the main properties for the case of characteristics function. In the next coming video we shall see the problems related with that of characteristics function.